Hi everybody, this is problem 7.4a, number 14, on constructing an abbreviated truth table. As always, for an abbreviated truth table, we're going to try to make the premises true and the conclusion false. First premise, not C or D. Second premise is not C and not E, if and only if, not D. We'll put the truth value under the main operator there. Third premise, not E, then C or F, and we put the truth value under the main operator, the arrow. And then the final premise is S or F. Again, put the truth value under the main operator. And the conclusion, we need to mark that one as false for purposes of creating an abbreviated truth table. Now, if S is false, we can start going back through this and take a look. In the final premise, we've got S or F, and we know S is false. So that tells us something. That tells us that F has to be true because S or F is a disjunction, and a disjunction is only true when at least one of the disjuncts is true. So we're going to put the T right there. Now what about the next place? Well, if we know that F is true, let's go back to the previous one, the previous premise. Well, at least we know this. We know that F in C or F is true, and that tells us that the disjunction C or F is also true. Now, where do we go from here? It may not be completely clear. C could be true or false, and that wouldn't change anything there. And for that matter, since we know that the consequent in this premise is not E, then C or F, we know the consequent is true, so not E could be either true or false. We probably need to look somewhere else. Let's take a look at this. We've got, let's see, have we got anything that we can do anything with? We know that not C or D is true. So that tells us that C or D must be false. Oops, let's get rid of that. I added an extra space I didn't intend to have in there. Now there's only one way for a disjunction to be false, and that's for both of the disjuncts to be false. So C has to be false, and D has to be false. And that gives us a little bit more material. Now we know that in this C or F, not that it will make a difference to this premise, we know that C has to be marked as false. We also know that in this not C and not E, C is false, and therefore the not C rather, that's going to be true. So if C is false, then not C is true. Okay. Doesn't look like we've got anything quite yet, but wait. We know that D is false also, and so we have this being true. If D is false, then not D has to be true, or TF, true for the not, false for the D. And we've got a true a true biconditional. Biconditionals are true only when the two branches or the two sides have the same truth value. So if we know that one side, the not D, has a truth value of true, and we know that we're assigning this biconditional we know we're assigning this biconditional truth value, the whole biconditional truth value of true, then the not C and not E also needs to be true. And the only way a conjunction like that can be true is if both conjuncts are true. So that tells you that not E is also going to be true. And if we know that not E is true, we can fill that in over here. And we say, and it looks like we've got values for every step. Values that allow us to say that all the premises are true and the conclusion is false. Now, all we need to do is go over here and fill in, this is the last step, fill in values on the left-hand side. We're going to fill in an F, false for C, false for D, false for E, true for F, and false for S. Oops, let's make that true for F, not false for F. And remove that extra space there. And if we've done this right, this should be invalid. Let's see. And we've done it. The argument is, in fact, invalid.